In the first problem on this page, it says Jackie will audition for the Crane School of Music in 14 days. She needs to increase her practice time each day to be competitive. So she asked two music teachers, Jeff and Steve, for their advice on how many minutes to practice per day. Each teacher's advice is plotted below. Whose advice follows an arithmetic pattern? So when we think about arithmetic versus geometric, arithmetic is like a linear pattern, so it's a straight line. The dots are Steve's advice. So I'm going to say Steve, an arithmetic pattern is linear. Which is shown for Steve in the graph. So something like that is a fine explanation. So now that we've picked Steve, it says write a recursive definition to represent the number of minutes per day for the advice you chose. So when we look at Steve, we need to first say what the starting value is, and it looks like the starting value is about 25. If I were to write out this sequence, it goes 25, 30, 35, 40, and so on in that pattern where we see adding the same number each time. So to get to the next term, we take the last term and we add, sorry about that, we are going to add 5. So this is the subscript n minus 1, and this is a regular plus 5. It says, Devin began running a month ago to get back in shape. The first day he ran 0.5 miles. Each day after that, he ran 10% more than the previous day for a total of 30 days. We're going to use the sum formula for the sum of a finite geometric series to calculate the total distance Devin ran over the 30 days to the nearest hundredth. So this is a different running plan. We're using the sum of a finite geometric series, and we see it's geometric because it's increasing by 10%, which indicates a multiplying pattern. So this formula is one of the few that is given to you on the reference sheet. Remember, instead of R, we're going to write B, just to remember it means the whole base here. So the formula on your reference sheet shows R, but we're going to write B. So his start value is 0.5. We want the whole base here. Sorry, I didn't mean to circle that. So for the 10%, that's increasing by 10%, so we want to use 1.10, not just 0.10. Now, if you're confused about that, if you try both, your answer with a 0.10 there will not make sense for what it would add up to over the 30 days. So then the last thing, the value of n is 30, so we're going to plug that in. If I type that in my calculator, I get 82.25 miles. Oops. Got crammed there with trying to write with a pen. So 85.25 miles. If you use the 0.10, I'm guessing you would get an answer that wasn't even that much bigger than 0.5 miles, and obviously it's at least 15 miles if you just stayed at 0.5 per day for 30 days, and we know it's increasing each day, so we expect it to be bigger than that. Number 12 says, in his first year at his job, Kyle made $12.50 per hour. In his second year at his second job, Kyle made $13 per hour. Assuming Kyle's wages increase by the same dollar amount each year, write an explicit formula for an arithmetic sequence which models the number of dollars n that Kyle makes per hour each year. So we're assuming a linear arithmetic pattern first. It's the same dollar amount. So our formula for that, an explicit formula, would be d times n minus 1 plus a sub 1. So that's one of our formulas we want to know. So plugging that in, the common difference if he's going from $12.50 to $13 would be 0.50 or 50 cents. N minus 1, n is our variable like an x, and then he's starting at $12.50 in the first year, so that's going to go in there. So the next one says, assuming Kyle's wages increase by the same percent each year, we're going to write an explicit formula for a geometric sequence which models the number of dollars n that Kyle makes per hour each year. So what we need to do for this one, to find the value of the base, we're going to be using this formula first off. So we have a sub 1 times b to the n minus 1. That's our explicit geometric formula. It's not as obvious to me what it's increasing by in terms of a percent. So I am going to do 13, the a sub 2, divided by 1250, the A sub 1, and that gives me about 1.04. I'm not sure if that's rounded. We're going to say we're rounding to the nearest hundredth if we need to. As I have an answer key, but I'm not sure the exact number. So this is our base. Our start value is still 1250. Okay. And I'm actually going to start the formula over again in a different color because this is starting to get a little crowded. So starting that formula over, we have A sub n equals A sub 1, so 1250 times 1.04 to the n minus 1. It says, if Kyle made $14.62 in his 5th year at the job, which formula best models his hourly rate each year? So we're going to find A sub 5 with each of the formulas. I'll start with the linear one. That would give me 0.50 times 5 minus 1 plus 1250. That's going to give me 1450. Pretty close. Let's see how the other one does. So this is from A. And then from B, we're going to use this formula. So we have A sub 5 would be 1250 times 1.04 to the 5 minus 1. And that's going to work out to be 1462. So it looks like the formula that best models his hourly rate each year is B. Okay, so we're talking about the formula in part B.